let's look at this previous problem from the topic rotation. It says, I have a thin wire of length L, so the length of the wire is L, and has a uniform linear mass density rho. What do you mean by uniform mass density? If the mass of this is m, if the mass of this is m, length is L, then m by L is your rho, right? That is what it means. So it's bent into a form of a circular loop like this. The center of the circular loop is O. All right. Now they've asked you to find the moment of inertia of this loop about the axis xx dash. Xx dash is in the plane, obviously, as it's very much visible. It's in the plane of the circle of the loop. So how do I find this? How do I do this problem? So first of all, it all starts. I'll tell you what are the concepts involved in this. The concepts that are involved are, first, the basic moment of inertia formula for a ring. The second, so this is one. The second concept is perpendicular axis theorem, and the third is parallel axis theorem. Let's see how. So first of all, I'll take an axis which is passing through the center and perpendicular to the ring, because for that I knew the formula. I know that if I have a ring of mass m, right, and a radius r, then moment of inertia about this axis passing through the center and perpendicular to it is nothing but mr square, right? So how do I get r? How do I get the r for the ring? If the length is L and it's bent in the form of a circle, then L is the 2 pi r, right? L is nothing but 2 pi r. So r is nothing but L by 2 pi. R is nothing but L by 2 pi. And mass is nothing but rho into L, right? Rho into L, using this equation. So I'll just substitute that in this. So the moment of inertia about this axis, O dash, let it be O dash, OO dash, right? So OO dash is nothing but m r square, where m is rho into L, and r square is nothing but L square by 4 pi square. So what you have is IOO dash equals to rho L cube by 4 pi square. Right. Now you have this. Now what we'll do is we'll use perpendicular axis theorem. However, what is perpendicular axis theorem? If I have an axis like this, and let this be your IZ, if I have two axes IX and IY, which are in the plane of the body, then IX plus IY will be IZ. This is the perpendicular axis theorem, where IZ is perpendicular to the body, but IX and IY are in the plane of the body. And remember, the body has to be planar. If body is not planar, if the entire body is not in one plane, I can't use perpendicular axis theorem, right? So it has to be planar. It is in the xy plane. Let the body be in xy plane. This is your Ix, this is your Iy, right? And their sum will then be equal to Iz, which is perpendicular. So that's how it is. Now you can see about both of these axes, mass is distributed symmetrically, right? So if you look at axis Iy, there are two loops around Iy. If you look at Ix, there are two loops having the same radius, right? So basically, this mass distribution about Ix and Iy are very symmetric. So Ix equal to Iy equal to some I, right? Because mass distribution is symmetric, and moment of inertia is all about mass distribution. So the moment of inertia is about both Ix and Iy will be same. That's equal to some I, right? So then I can say I plus I will be Iz, I plus I will be Iz. So 2I will be Iz, right? And what is your I? What is your I? If I have an axis, this is your Iy, right? So Iy, this is your I. This is your I, which is passing through the center and parallel to xx. So I is nothing but Iz by 2. Iz is nothing but rho L cube by 4 pi square. So I let this be I dash, right? So I dash is nothing but this by 2, this quantity Iz by 2, right? So rho L cube by 8 pi square, right? Now I know I dash, which is an axis which is passing through the, so I use this basic moment of inertia formula, I use perpendicular axis theorem, I am supposed to use parallel axis theorem now. I have two axes which are parallel to each other, separated by some distance r. I know what that r is, right? Separated by distance r. I know moment of inertia about an axis which is passing through center of mass. I need this Ixx dash. So using perpendicular parallel axis theorem, I'll just use the simple expression Ixx is nothing but I dash, because I dash is passing through center of mass, plus m into the distance between the two axes, which is r square. So I dash is nothing but rho L cube by 8 pi square, rho L cube by 8 pi square. M is nothing but rho L. R square is nothing but L square by 4 pi square. I'll take the sum of these two, that's my Ixx, and that's nothing but 2 plus 1, 3 rho L cube, 3 rho L cube by 8 pi square. So do I have an option 3 rho L cube by 8 pi square? Yes, this is the answer.